Hello, everyone. Thank you for joining this session. My name is Isabel. I am an event planner for the Reactor, joining you live from Sydney, Australia. Now, before we begin this fantastic session, we have a quick housekeeping. We are committed to fostering a welcoming, inclusive, and supportive environment for both our audience and presenters. While we absolutely encourage engagement in the chat, please let's keep our comments respectful and constructive throughout the session. This session is being recorded and will be available to view on demand within 24 to 48 hours right here on the Microsoft Reactor YouTube channel. Thank you all for joining us on this session that is part of the Season of AI series. The session is called Build Your Code First app with Azure AI Agent Service. I am excited to introduce our fantastic speaker, Zayi, and will now be handing over the spotlight to him. So take it away, Zayi.
Thank you very much, Isabel. So good morning, good afternoon, and good evening, wherever you are in the world. Hello and welcome to the Build AI Agents in Azure. My goal for this session is to teach you the core concepts of building agents using the Azure AI Agent Service. So let me just quickly introduce myself. So for those who have LinkedIn, you may add me up here in this profile above. So my name is Ziggy Zueta. I'm also a LinkedIn learning instructor. So pretty much all the information that we get within Microsoft, the Bible, as we call it, is the Microsoft Learn website. Wherein with Microsoft Learn, you can get all the information with regards to everything about Microsoft. So in the Azure AI Agent Service, for example, there's a whole lot of information that you can get in Microsoft Learn. What we do here in LinkedIn Learning is that we provide video content. So pretty much all the Microsoft Learn that you get is text-based. So what we do in LinkedIn is that we provide video content to supplement that information. So within LinkedIn, I'm contracted to provide most of the Microsoft AI videos. So I do have around 8 videos in which all the Azure AI services I've been covering. I'm also a Microsoft Most Valuable Professional. So it's a technical award given to experts all over the world. As you notice, Microsoft is pretty much covering a lot of bases. So this MVP award is based on a specific technology in which I was given the award in the field of AI. I'm also a Microsoft certified trainer. So I do provide a lot of trainings globally and helping people and organizations become certified. And I do have some certifications, among them the Azure Solutions Architect and Azure Power Platform Solutions Architect, among other things. So I did mention that I do have LinkedIn courses. So here's one very popular LinkedIn course that you may want to go through. This is the Microsoft Azure AI Essentials Professional Certificate course by Microsoft and LinkedIn. Unlike other LinkedIn courses, wherein upon completion you get a LinkedIn Learning badge, what makes this course unique is that after you complete the course, you can take an exam, and once you pass it, you're eligible to get a Microsoft Professional Certificate. So with this course, Azure AI Essentials, you'll practically cover all the things about Microsoft Azure AI. And it's actually a good preparation for you if you want to actually get certified within Microsoft Azure in AI 900. So let's discuss about agents. Before that, let's provide you a use case. In our use case, we have a company. So there's this company which I created. I created this logo using Copilot, and then this photo that you see here with products is all Copilot created. So we have this fictitious company called Adventure Ready Travel Company, and the company they have a set of requirements. They want to create an agent that wherein when customers ask queries about products, the agent is able to provide product info. In addition, the company has partner restaurants. So in different countries that they are focused on, excuse me, they have restaurants that they have partners with, in which if a customer asks where they can eat in a specific country, that the travel company will recommend these restaurants. The agent can also provide updated weather. It can provide budget information if they want, if a certain customer would like to visit a specific country, and it can even probably eventually book orders or book hotels and flights with partners. Now, in a typical large language model, when you do chat with Copilot or Chat GPT, when you ask a question, can you give me luggage recommendations? The large language model is able to respond back, but unfortunately, it's responding based on the data that it has been trained on, in which case it's mostly getting information from the internet. So as a result, when you're asking for language recommendations, it's going to provide Samsonite, Tumi, and Delcy as an example, and these are publicly available information. And these are the products that we are actually not selling. What's happening is that we want to sell our own set of products, in which is our own data set, which is not available online. So the question is, how can an agent help us? So before I actually go through the details on creating an agent, let me show you first an agent that we created. So let me provide you a demonstration. So what I did was, I had this Azure Ad Service. So I deployed an agent and deployed it using the Azure App Service, and we'll discuss how to actually do this. So I deployed this in a framework called Chainlit. So it's a popular open source Python framework that allows you to have conversational AI applications. So my logos here, I have some starter prompts here in which let's ask a question. So restaurant recommendations. What are some good restaurants in London? Here, what will happen is based on this query, the agent will actually go through the information of the company on what are the specific partner restaurants for London. So these are not coming from the internet. I'll show you later that this is a set of as a list of restaurants that the company is a partner with. So from here, okay, so it's providing a recommendation on specific restaurants that we want to provide. And then from here, let's ask, okay, what is the weather there? And since this is a conversational AI application, when we mention there here, it's referring to London. So it's actually getting past information. So the weather in London is currently cloudy with a temperature of 8 degrees. So I hard coded the information here, but what should happen really eventually is that you're supposed to access an API, which I'll show you later. We can access an API like the TripAdvisor. And then we can ask, okay, I need a laptop bag for my travel there. What can you recommend? And in this case, it's going to look for our specific products. So let me show you what our products would look like. I have here a set of Word documents in which I uploaded all of them within Azure AI Search. So here we have around 18 products in which let's open one document. So this is what the document would actually look like. So we actually want to sell these products. And when people ask questions about our products, they should only come from these data and should not come from any internet data. Okay, so let's close that. And you can see here, I need a laptop bag, and it's providing laptop bags that we are selling, and it's even providing sources. So here are the source of our documents, just to show you that it's not coming from internet data. And then from here, you can actually reset the chat and then even ask other questions. Let's say budget recommendation. So if I have a budget of $300 for 4 days, where should I travel? So in this case, this travel company is only recommending three countries right now. So either London or Tokyo and New York. But in this case, for this specific budget, you can go to London and Tokyo, but not New York. So that's a demonstration in which this is actually a production ready application because this is an agent written in Chainlit, hosted in Chainlit, and I mean we use Chainlit to implement the agent, and then from here we use Chainlit rather and the Azure AI Agent Service, and we hosted it in an Azure App Service. So we'll discuss how we can make that happen. Okay, so going back to our PowerPoint presentation, before we actually discuss what the Azure AI Agent Service is, let's discuss first what an agent is. And if you look at the internet, if you look at, I mean, the industry right now, there's actually no specific definition when it comes to an agent, but let's try to discuss it based on two sources. One is coming from Semantic Kernel, in which what they're saying is an agent is a semi-autonomous software that can be given a goal and will work to achieve that goal without knowing in advance exactly what it's going to do or what steps it's going to take. That's actually the lengthy definition. I would rather have this definition here. I think it's from LangChain or LangGraph. It says that what they're saying is that an agent is a system that uses an LLM to decide the control flow of an application. So what do we mean by this? Let's talk about a non-agent system first. So current systems right now, which are non-agent or probably back in the day, when you have an application, and this application would have three functionalities. It can provide weather information, it can book a hotel, and it can book a flight. What you normally see is that there's a menu-based if and else condition statement, wherein they'll provide you a choice. Okay, please enter your choice. Is it get weather? Is it book hotel or book flight? So this is probably in a console application. Or in the case of a website, the person has to actually go to the actual weather page or the book hotel page or the book flight page. And then let's say that you decide to choose book hotel, what will happen is there will be another set of flow in which they'll ask you, please select a country. Is it going to be USA? Is it going to be France? Or is it going to be Australia? So that's a typical non-agent system wherein the user has to decide based on if and else conditions how the actual interaction will happen. Now, in an agent system, what will happen is you still have the same flow, but the goal now is to have a large language model decide on what to do. So, for example, if I ask a question, I want to book a hotel in the United States. Based on that specific query, the large language model will already understand that based on that query, we need to go to the book hotel function or the method, and then from there, go and book a hotel in the United States. In other words, imagine that there's actually a person at the back end. So in a normal case, in a customer service operations scenario, if a person asks, okay, I want to book a hotel in the United States, there's actually a person that will decide, okay, based on that specific request, I need to go to my book hotels information and I need to go to my United States information. But now, instead of having a person do that, we'll have a large language model decide on what to do. Okay, so it sounds magical. Let me show you how we can actually do that. So first and foremost, we need to understand that the agent needs to accomplish three things. Number one, it needs to reason over a provided business process. Number two, it should be able to retrieve context to complete the process. And number three, perform an action for the end user. So in other words, let's say we want to ask the question, I want how many hotels are available in the US, in New York rather. What will happen is based on that question, it should reason out that, okay, we're actually looking at the hotel bookings uh, process in which we retrieve the specific information for that hotel in that specific location. And then from there, perform an action would be either providing the information or to actually book the hotel itself. Okay. So how does the adventure ready travel agent work? There's actually a lot of frameworks available right now out there in the market. You can have LangGraph, LangChain. Within Microsoft, we have AutoGen, we have Semantic Kernel, and just recently we have the Azure AI Agent Service. So it's actually right now in public preview, but eventually, hopefully soon, it will become readily available. Uh, so, I mean, right now it's readily available, but it's still in public preview as of this recording. So, what does the Azure AI Agent Service do? It can securely build, deploy, and scale AI agents for you with ease. So, I'll show you later through quick coding. So, there are actually two ways to do it. You can create an agent through the Azure AI Foundry portal in order to demonstrate the capabilities. But for you to be able to deploy it, the way that I did it with Azure App Service, you need to use the Azure AI Agent SDK, in which case I'll show you an implementation written in Python. But before that, since I'm nearing my demonstration, let me just open first my GitHub code spaces to enable my demonstration while we talk. Okay, so going back, besides being able to deploy quickly, you have a lot of extensive data connections. There's a lot of connections easily with Azure Functions, with a TripAdvisor API, with Bing, with Azure AI Search. So a lot of extensive data connections. Right now, there's actually quite just a small number, but eventually, I can imagine Microsoft extending all of these to a lot more connections. And then from here, you have flexible model selection. Uh, you can use OpenAI, you can use DeepSeek, you can use Mistral, and all the other different models. I mean, 2 years ago, if you're having this discussion, normally Microsoft would probably only sell OpenAI models. But now, we're now a little bit more flexible. So it's not only OpenAI now. If you want to use a Llama model, you can also do so. And then, of course, enterprise case security. Since we are actually using the Azure platform, then the enterprises are they can sleep at night to know that their data is always going to be safe and that the interactions here will not be shared outside and will not be used to train the AI model. So let's talk about the architecture of the agent. Number one, our agent app is in Chainlit. So I'll discuss what this Chainlit is. So it's an open source Python framework. And then this Chainlit will have the code logic written in Python. And we hosted it in the Azure App Service. And then at the back end, we have the Azure AI Agent Service, in which we provided the agent instructions and a specific model. In this case, we used an Azure OpenAI GPT-4 Omni model. And then from here, you can provide it a lot of knowledge and tools. So we'll discuss what this function calling is about. There's a ready-made Azure AI search tool. You can even connect it to Azure Cosmos DB, and I'll also demonstrate. You can have a trip advisor tool as well. Okay. So how does this AI agent service work in action? When you actually code, there are a couple steps you need to do. Number one, you need to create, well, step zero is to create a project in Azure AI Foundry. So that's one. Two is you will create an agent. So I'll show you how to do that programmatically and through the portal. And then step two would be to create a thread. So this thread is to contain all the messages that you have. So back in the day, for those who probably may remember, when you're chatting in ChatGPT or Copilot, um, there's actually a specific character count that you can add when you provide the message, and then once you start chatting along, once it exceeds a certain number of interactions, the system will say, okay, we need to restart because there's too many histories already. There's too much chat history. What's happening there is that on the back end, back in the day, because right now when you're talking to ChatGPT and to Copilot, it's actually some sort of agent right now that's happening. But before, a developer had to manually recreate the chat history. So every interaction needs to be added into a list, into an array, and then send it off to the large language model so that the model will be able to understand the context. But now with the agent service, with the thread, the system automatically handles the past interactions for you. So once you create a thread which contains all the interactions, you can start adding messages to the thread. And after you add the message, you run the agent for it to respond based on your message. And then from there, you check the run status, and then the agent will display the response. You check the run status because it can be processing, or once it's completed, it will display the actual response. The agent is ready to provide the response. So how do you set it up? Number one, you need to create an agent. So we create an agent here, adventure ready travel agents. I'll show you how to create an agent through code. Then you need to provide it instructions. So this is mandatory. So you need to say that, okay, you're an AI travel agent. You'll answer questions about travel based on the tools provided to you. And then from there, you need to specify a model. It can be OpenAI, it can be Llama, it can be Mistral, Cohere, and all the other models available out there. And then as an optional piece of work, you can provide it knowledge information. So you can ground it with Bing search. So in this case, every single question, it will refer to Bing. It will search Bing for the information. Or in the case of file search, what will happen is you will upload files into the agent, and the agent will answer questions based on the files that you provide. Or it can be Azure A Search, in which you have an index in Azure A Search, and once you start asking questions, it will get answers from this resource. It can also be Microsoft Fabric, or you can use licensed data, in which case we'll demonstrate TripAdvisor. You can also provide it tools. So function calling, I'll demonstrate this to you, but what's happening is you provided different functions, and based on the description of the function, the large language model will decide what to use. Then you have code interpreter. With code interpreter, you're practically giving the agent a sandbox environment in which, based on a specific question, if it needs to create code and run code, it will use its own sandbox in order to develop the answer, to create the answer. So this I will demonstrate as well to you later. And then you have all the others, Open API specified tools or Azure functions. So now that you created the agent, you provided the instruction, the model, the knowledge, and the tools, then you create a thread. In which case, based on the question, what is the budget for travel in New York? Based on this query, the system will decide, okay, I need to use the fetch budget tool, and based on this specific query, New York is what we need. We fetch budget in New York. It will create a message, and the agent will respond back with, here's the travel budget for New York. And then from here, what is the weather there? And based on that there, the system knows that, okay, we're talking about New York here. We need to fetch the weather in New York and then provide a response back. So enough of the talk. Let's actually do some demonstration. Okay, so I demonstrated to you what it will actually happen with the app service. Let me demonstrate it to you through code how we implemented it. So okay, let me show you my, sorry, let me show you my code space. So number one, you need to have, well, first and foremost, you need to log into, what do you call this? You need to log into your console in order for this to work. So you need to log into your Azure account, AZ login. And then from here, get this code and do a device login. So this is needed for, so later I'll show you where it's actually going to be used for. So let me just do this initially. Okay, so I need to log in first. Sec, password, and provide a code. So within the terminal of CodeSpace, so I'm actually using GitHub Codespaces. So it's actually an environment that allows you to do coding using a virtual. There's the virtual environment that will provide you. So instead of having this in my local environment, I'm using a server out there that GitHub Codespaces provided me. And this is actually free. So you have 100, I think 160 hours of coding available for you in GitHub Codespaces with a free account. So anyway, going back, so we've logged in already. What we did was I created first a project. So how do you create a project? You need to go to Azure AI Foundry, and then from here, click create a project, and then just put a project name. So I already created that. I have this Ziggy AI Agent Project 001. So this is my project that I will use to create my agent. Okay. So within Python, you need to install the AI projects library and the Azure Identity library. So I will not run that anymore because we've done that already. Now we need to define all the functions that our agent can call. So let me discuss this first function called fetch attractions. So number one, in this day and age, when you're coding in this day and age of coding, your function name should be intuitive. Meaning, if I show this off to another person, the other person will be able to understand what this function means. In which case, when you say fetch attractions, the other person will already know, okay, this function fetches attractions. Second one is that you need to put a doc string. So in this doc string, it fetches the attractions, places to visit, things to do for the specified location. So the function is fetch attractions, in which the person will already know, okay, this fetches attractions, and it expects a location string. So the location string, the location to fetch attractions for, and it returns the information as a JSON string. Why is this important? Because we are telling the large language model what the actual function is about. So that later on, if somebody asks a question, the model will already know that, okay, I actually need to go to you. I need, if a person asks about attractions, the large language model will be able to understand that, okay, based on that query, I will go to fetch attractions. Okay, I'll show it to you later how that happens. So now what I did was I created mock attraction data right now. So in New York, these are attractions. In London, here it is. For Tokyo, here it is. And then we just returned the information. We also have fetch weather, in which it expects a location string. And we have the doc string as well for fetch weather, which explains what fetch weather is. And this is the information. So all of these are hard coded right now, but in reality, these functions should actually call an API. We have fetch weather, so these are our restaurants information. We have fetch budget, in which these are budget information. So all of these are hard coded. The only thing that I did not hard code is my fetch product information. So for this fetch product information, it's actually expecting a user query. And I also provided the docstring here. And then what it does, this whole line of code here is we connect to number one. We get first my Azure search service and open AI API versions and endpoints and keys. I create a search client in Azure AI Search, and then from there I create an open AI client. So what will happen is based on my question, the LLM will get my query and search in Azure AI Search all the products that I have based on that query. And then from there, I'll provide the response back. Okay. So I defined all of those functions and I put them all in a list. So all of these are just function definitions. I put them in the list and this is where the magic happens. So let me just run this first. Okay. This is where the magic happens. Number one, we create our agent. No? In order to create the agent, we first need to create a project client. So what's happening here is that we need to connect first to our project connection string. So if you go to Azure AI Foundry, this is my AI Foundry project, and this is the connection string here, this one here. Okay. I actually loaded it in order for me to create a project client. So let's run this. And this 3 lines of statement here is actually where the magic happens. Remember this user functions, which we defined. It's a list of all the different functions that we have. I placed it in a function tool and a tool set. Okay. And then what happens here is that when we create the agent, the model is GPT-4 Omni. The name is my agent. And then the instruction is you are an AI travel agent. Use the provided functions to help answer questions. And here, this tool set, we provided it to the agent. So remember earlier when I told you that in a non-agent system, you probably need to create an if and else statement based on the user interaction. The flow will be based on that if and else statement. With this specific code here, toolset is equal to toolset. We're providing the agent, which is the GPT-4 Omni as the brain, the toolset, and then from there, based on the query, the system will already decide what tool to use. Okay. So once you created the agent here, if you go to AI Foundry, under agents, you see here that my agent was already created. Okay. This my Chainlit agent is the Chainlit agent that I showed you earlier, that I demonstrated earlier. Okay. So we created the agent, and now we need to create a thread. So remember, the thread contains all of the different messages for the user and the agent. Okay, so we created a thread, and here I created the helper function that runs the agent. So I'm not bogged down on what this actual code is. I have a lengthy implementation here. There's a simpler implementation for this. I created this lengthy implementation just to show the thought process of the agent. But in general, what it does is, number one, so the first step is to create the agent, the step one. Step two is to create the thread. Step three is to add the message to the thread. So what I showed you in the presentation. Step four, once you add the message, you run the agent. And then step five, you check the status. So it's either in progress or requires action. And then if it requires action, it will call its tools. So I'll show you later what that will look like. And then finally, once it's already available for display, once the run status is complete, we display the message. So let's ask the question here. Okay, so hello, what are the places I can visit in Tokyo? So we created the message, we created a run, the status is requires action, and then based on the query, the system already found out that, okay, based on your query, we need to use the fetch attractions function And the argument here is that based on that query, we need to look for the Tokyo location in which we need to get the attractions in Tokyo. And then from here, you can see, okay, the response is, here are some popular places to visit in Tokyo, and then we have this list of places. Now, so you probably be wondering, okay, this can come from the internet. No, because let me show you all the attractions. So there are 5 of them, and then we actually define those 5 here. So 1, 2, 3, 4, 5. Okay, so it will only provide the information that we actually wanted it to provide. So here, let's ask the question, what is the weather like there? So there would mean Tokyo. So we create a message, create the run, create the status. And then from there, based on that question, the agent decided, okay, we need to use the fetch weather. And then the argument is Tokyo. And then from here, okay, the current weather in Tokyo is rainy with a temperature of 22 degrees. In which case, that came from the information that we provided above. And here, let's ask a question. I need a suitcase. What do you have available? So in this case, okay, create message. We create a run. We see that the status requires an action. And then based on this question, it now needs to provide, it needs to use the fetch product info function. And the argument is we provided the user query, the suitcase. And now it's searching for my data sources for all the suitcases. And here are my suitcases that I'm selling. The Globetrotter Elite suitcase, Nomad Traveler suitcase, Voyager Pro luggage. So to show you where that came from, it came from um, this product set that they provided. Sec. So here, it's actually one of the products here. So the Voyager Pro luggage is here, the Elite suitcase, and Nomad Traveler suitcase. So I'm showing it to you in my downloads folder, but it's actually uploaded in Azure AI Search. And then I only have $300 US. Where can I go for 300 days? So based on this query, it decides that it needs to use the fetch budget function. And then from here, okay, the budget is for New York, here it is, and then from here it's providing information. So again, we did not create any if and else statements. What we did was, when we created the agent above here, in this line of code, this was the only mechanism for because a lot of people were asking, how does the agent decide on what to use? Number one, we created all the functions above here. We created all the functions above here, and we need to provide a docstring. So this function name, this parameter here, the large language model understands that this is fetching products, and it expects a string, user query of type string. And we also place in the docstring what this specific function is. Okay. Same thing with fetch budget. Okay, so fetch the budget information for the specified location, and same thing with fetch weather. So that's the first thing you need to do. You need to define the functions, define them properly, name them properly, and then you place it in a list. And then, again, as I mentioned, the magic happens here. You put the list into a function tool, put it in a tool set, and give that tool set to the agent. And that's about it. There's no if and else statements that we created. Okay. So that's how it works through code. So you can actually see the Python implementation as well of this in Microsoft Learn. And then finally, once you're done, you need to start deleting the agent. Okay, so you need to delete the agent, in which case, once we refresh this, the agent gets deleted. So notice you need to ensure in your code that you actually delete them. Okay, because if not, what will happen is the system will continue on creating. So in this case, for my for this agent that I created, once I click on X on this, I programmatically deleted the agent. No, because if you don't do that, um, so if you don't do that, all of these agents here will continue to accumulate, and then you may probably incur some cost. Okay, so this one, for example, for this Chainlit agent, I will have to delete it so that I don't incur additional cost. So now I demonstrated to you through code how I can do it. Let me demonstrate it to you through Azure AI Foundry. So all you need to do is to number one, click new agent here. And what I'll demonstrate to you here in this case is I'll create a code interpreter. In which case, I will show you the code interpreter in which under actions here, I'll add an action. I'll choose code interpreter and I'll select my local files. So in which case, I'll go to my test data. I'll show you, I have population data here. Let me open here what it looks like. So I'll open this up. I'll show it to you. So this is I'll open this up. So these are actually CSV files wherein it contains the UID, ISO code, etc., and the population per UID, and then you have the population by admin in which you also have a UID. I'm not telling the large language model how these CSV files are connected, but the large language model will already know that based on this column, that's how we connect them. In other words, in this day and age, when you create your functions, it should be intuitive enough that a person will understand. When you create your table or your CSV file, the headers should also be intuitive enough so that the large language will understand that if you're looking for the population in a specific country, it will look for the population, it will look for country. Okay? So let me close that. What I'll do is I will upload these two files here in Code Interpreter, and I'll click Upload and Save. And now, once we added those two files in, I can try it in the playground. And then from here, we'll ask the question, okay, what country has the third largest population? So again, as I mentioned, what Code Interpreter does is we'll provide it a sandbox environment. And then from here, based on the CSV file, it will create Python code in that sandbox environment. And it will run that Python code in order to answer questions on my dataset. So in this case, okay, the third largest is United States. Run info. Let's see here. It's not showing the code right now. Let's see. Hold on. It normally shows view code. No, yeah. Okay. Let's ask another question. Okay. Give me a column chart that in descending order that shows the top 10 countries with the highest population. Okay, so now you see here, it's providing a code interpreter, and based on that, it's providing you Python code. So this is a Python code. It needs the mat. So for those who know Python, in order to show a graph, you need to have the matplotlib library, and then from there, using Python code, it will create a chart in which you have the different populations per country, and then here we can say, okay, I want you to add the population data on top of each column. And then from here, okay, now you can see here that another set of Python code in order to adjust the chart, okay, in order to customize the chart. And now you can see here that the chart is now with a new set of data based on the information from the CSV file. And then from here, okay, give me a chart wherein we get all the countries, the top 10 countries with the highest population that starts with a specific letter. letter S. I want to get all the countries with the letter S. And then from here, I want to get all the countries that starts with the letter S. How many countries there are, and then what is the oh, no countries. Yeah. So, well, there's an issue with my query there. But anyhow, what I'm showing you here is that based on your queries, it's going to create Python code in order to be able to answer questions on the dataset. Okay. So that's on code interpreter. We have here, let's go back to the agents. We have here, for example, a built-in system with TripAdvisor. So for example, I have here a TripAdvisor API in which I raised this up with TripAdvisor. So you need to add here the API restriction in order for you to be able to access it. Um, let's go to the agent. We created an agent and we added knowledge. So in this case, we added the TripAdvisor knowledge. You can check out in Microsoft Learn how you can set that up. But the first thing you need to do is to have an API key in TripAdvisor. So from here, going back here, let's try out this TripAdvisor. Ask the question, what are the top 10 restaurants in New York for, let's say, Chinese? And here it will search for your TripAdvisor information, and it will provide TripAdvisor restaurants from TripAdvisor. And now let's ask the question, okay, give me reviews for this restaurant. The Golden House Chinese restaurant that TripAdvisor recommended. And from here, these are the ratings in which it's going to provide. So here are some reviews. And if you want to click on the full review, let's click on a link here. Let's click on this. And then from there, it will actually refer me to this TripAdvisor website that says the actual review for this specific restaurant. So going back, I demonstrated to you how we can create an agent through Python. And you can create an agent with Azure AI Foundry. The reason why you have AI Foundry is for you to demonstrate it, for you to be able to demonstrate and see how it actually functions. But if you really want to deploy it, then that's the time you need to use the Azure AI Agent SDK, in which there are different flavors. Like there's in .NET for sure, C# and Python. I'm not yet sure about the other languages. Then I'd like to discuss with you function calling, which we demonstrated earlier. So we created the instruction here, and then we created our function, in which case, as I mentioned, the function needs to be intuitive, and then you have a docstring to explain what the function is about. And then based on the user query, the large language model will automatically orchestrate and determine that based on this query, we need the fetch weather tool, and you're actually looking for the weather in New York, and it will return the information. So lastly, I'd like to show to you that we're actually using Chainlit. The website that I showed you earlier is actually using Chainlit. So it's an open source Python package to build production-ready conversational AI applications. So the good thing about this is you have a chat lifecycle here, in which in the on start, you can create an agent. On message, every time a user is sending a message, you will send it here. And then once you close the browser, you can delete the actual message on the on end. And then there's a lot of integrations available, and you can easily customize the front end. So let me show you what this Chainlit application looks like. So let me show it to you through code. Okay, hold on a sec. Let's open my GitHub repository. In a sec. Okay, let me show you the code for this. Hold on. So this is my Chainlit repository. So here in Chainlit, you have this app.py. So first and foremost, you need to install Chainlit. You can actually look it up in Chainlit, search it in internet, Chainlit here, and then you can see this documentation on how to implement it. So first and foremost, you need to install the Chainlit uh, package. And then in pure Python, for you to have your first Chainlit application, just put this up and then run the application here. So what happens here is that you actually echo it, but let me show you what it looks like through code. So here in my Chainlit application, we define the weathers, which we did earlier. So we defined the weathers. And then we created the user function. So we did that. We created also the run agent helper function, which I also showed you earlier in code. What's important is on the on start, what we did was every time you start the application, what I did was you create an agent, you create a project client, and you create, in this case, my AI search tool. We add all the tools, we add all the functions and the AI search in the tool set, and then we create the agent in which we assign the tool set to the agent. And that's about it. That's what it does. And then also we created the project the thread. We created the thread. And then that's on the on start. So this is the on start of Chainlit. On the on message of Chainlit, every time a user sends a message, we're actually running the agent in which we're providing the message.content would be the user message. We have the project client, the thread, and the agent. So we're passing it to get the agent response, and then we're just merely displaying the response through the screen. And then once you end the agent, we'll delete the agent so that we free up resources. And then these are the starters, which I showed you earlier, in which I customize it. There's a weather query starter. So let me show you again what it looks like. Let me open it again to you through the app. So these are the starters that you see here. Okay, so there are 6 of them. These are the 6 starters that we created, in which I added, icons. So pretty much just very easy to customize. So going back to my presentation, so we created that in Chainlit, and then afterwards we deployed it in Azure App Service. So with App Service, you can run web apps, mobile backends, and RESTful APIs without worrying about managing the underlying infrastructure. So I don't need to get a virtual machine and to determine, how much capacity the virtual machine can handle for my user requests. I have it in an app service, and it will auto scale and can support a wide variety of web stacks. In this case, we're actually using Python. And then if the app is containerized, you can deploy it as a custom container. In fact, that's actually what we did. So going back here, I have a Docker file, which it was being used by the app service. So this is a Python 3.12 Slim image, a Docker image, in which in that image, we actually run the requirements. So remember, you need to have Chainlit and these two, libraries to run. And then I have a startup file here, in which case in my app service, so let me show you my app service. Where's that? Hold on. I have so many here. Okay, so here's my app service. What I did was in my app service, in the environment variables, so remember, in our Chainlit application, every time you create an agent, you first need to connect to your project connection string, and you need to connect to Azure AI Search. So let me close, wait, hold on. Let me close that. In my app service, I have my index name here, the AI search, and the connection string. So there's actually hidden in code so that if there's a new update in my configuration, I just do it here. And then under configurations, you can see here that we're using a Python 3.12 environment. We're using startup.sh as the startup command. And then most importantly, on the deployment center, this web app is connected to my GitHub, to my Chainlit GitHub repository. So every time I make a change, if I change anything in the code in my Chainlit repository here, this one. So if I make any changes here, all I need to do is to modify it here, upload it in my GitHub repository, and then here I'll just need to click on sync. So once I click on sync, all the new so there's this actually using DevOps, wherein if I modify anything in my Chainlit repository, I just click on sync here. It will automatically get that updated data and then redeploy the whole thing immediately. And then from there, you can see an updated website or updated application. And then again, through the overview tab, you'll be able to. So let's close this again. So you can open. So what I did here is that every time I open it, I create the agent. And then every time I close it, I close the agent. No? So yeah, so this is practically what it does. And it gets the inputs as well. So in this case, I open it, it creates an agent. I run this, it goes through on message and then looks for the individual functions that I need, in which case the weather function, and provide a response back. And then once I close it, let me show you what it looks like. So if I go to my AI Foundry portal, loading, take a while. So you can see here the agents. So this is my Chainlit agent. So if I close this, it actually, I opened a lot already. It deleted one of them now. So actually did not delete the other one which I opened. So I opened a lot of browsers. So I can actually delete it also here or delete it programmatically. So also the code agent you need to delete. So this is the one that we created manually earlier. Okay, so that basically sums up the presentation. So takeaways, agents can perform a lot of complex tasks. You can actually provide it custom knowledge, actions to meet various business needs. We demonstrated how you can create agents using Azure AI Foundry for you to demonstrate it through a client. But if you really want to deploy it, then you need to use the SDK, either C# or Python, in which case we use Python. We deployed it using Chainlit, and we actually hosted it in an Azure App Service. So what are the next steps for you? You can create agents in Microsoft Learn. There's a lot of information. The Azure AI agents is available in Microsoft Learn. You can see the Python SDKs as well here. And in fact, if you take on a screenshot of this QR code, there's actually a ready-made Microsoft Learn module for you to create your first agent. But obviously, you'll have a different data set and different example. And it's obviously not deployed in a production setting the way I did it, but it gives you a good start. Also, another next step is when I demonstrated to you the Azure AI Agent Service, its current limitation right now is that it can only create a single agent. Um, you cannot do a multi-agent system right now with the Azure AI Agent Service. So what they're recommending is that if you want to create a multi-agent system, you need to what do you call this? Integrate this with AutoGen or with semantic kernel. So if you take a screenshot of this, I do have a course in LinkedIn that actually discusses how you can create agents in semantic kernel and AutoGen. So with this QR code, you can get a free 1 month subscription in which you can try out, see the video in order to learn more about AutoGen and semantic kernel. Okay, so that basically sums it up. I would like to get the floor for any questions, and if you're shy, then you can send me a direct message in LinkedIn. You can connect with me, and I will be able to answer questions there. So let's see if there's any questions from the audience.
Thank you, Sayi. That was a really good presentation. I have one question right here from AJ Kumar, and AJ is asking, what is the difference from NLP app?
I can achieve. Okay, what's the difference from a normal RAG application? I guess an application. I can achieve same results using Q&A. Okay, so I think you're missing the point here. So with a Q&A, for every question, there's an answer. It's only providing answers back based on, it can be a RAG application wherein you're getting information from a product set. But as I mentioned, when I showed you earlier the different functions, so let me show it to you again. All these different. Sorry, am I still sharing my screen?
Yes.
Okay. So going back here, this can be calling a database in order to save information. So it can be let's say it can be here book an order, and instead of getting information, it will get the order and then place it in a database. Okay, so it's not just answering a question but doing a specific action. So maybe next time when they provide a demonstration in this, I will create code in order to book a product, an order, and save it in a database. So that's really one. So it's not only answering questions; it can also do actions. Right now, I hard coded it. I hard coded here the information, but what should be in reality is that based on your query, it will do a specific set of actions, and these are the functions. These are the actions. So right now we're just fetching information, but it can be, booking a hotel order, or in this case, I created customized code here in order to get information from Azure A Search. It can be the case that I will call an Azure function. In that Azure function, it will run a specific set of tasks. So yeah, it's not just a Q&A application.
Great. Thank you, Ziggy. We are running out of time, so we do have to wrap up the session. But again, you can see Ziggy's LinkedIn profile right here on the screen if you guys happen to have any questions. And once again, if you missed any part of the session, if maybe you joined us a little bit late, this session was recorded and you will be able to view it on demand on the Microsoft Reactor YouTube channel in 24 to 48 hours. And in case you missed it, we did have a session with Ziggy on Tuesday called Unlocking Insights Using Azure AI Content that I have just popped in the link in the chat for if you guys want to check his session out and maybe learn a little bit more in case you missed that session. And once again, this session will also be available in 24 to 48 hours. Thank you once again, Ziggy, for this fantastic session. And thank you all for joining us today from all over the world, by the way. Ziggy, we had people from Germany, Nigeria, Korea, Pakistan. So this was even Brazil. So this was a really, really good, interesting session. So thank you, Ziggy, and thank you for everyone for joining us today.
Thank you,
Uh,
Isabel.
yeah, no problem. So, with that being said, this session has now come to an end, and we'll see you guys on another one. Thank you all.
Okay, bye. See you guys soon.